Hello, and welcome to Aggressive Physics. Today is day 110. What I'd like to discuss today is the oil drop experiment. Now, we've been dealing with the charge of an electron since the beginning of this section. And the charge of an electron we know as 1.6 times 10 to the negative 19 coulombs. We know that that is the same as the value for the charge of a proton, but the proton has a positive value. Well, the person who came up with this value was Robert Milikan. And what he did is what we call the oil drop experiment in order to determine that. And the oil drop experiment used the electric field in order to help determine the charge of the electron. What Milikan did was he set up a parallel plate because he knew that that was a uniform field. And he sprayed little drops of oil almost through a perfume type bottle, so it was atomized, so they were really small droplets, and he viewed how they would interact with the electric field. As he atomized these and sprayed them inside the field, they would become charged. Well, as they charged, they also had mass, so they would fall towards the Earth's surface. What he did was he adjusted the voltage of the field so that the oil drops would fall at a constant rate. Well, when they did, if they had a constant velocity, he knew that the downward force of gravity was equal to the electric force upward. So if he knew the charge on each end of the parallel plate, as he dropped the oil droplets in between, he was able to know that the oil drops were in equilibrium. Even though they were falling, because they weren't falling with any acceleration, he knew that the net force had to be zero. Well, that allowed him to figure out the force of the electric field on the oil drops. Now, the problem with the electric field equation, which is E equals F over Q, he knew the force and knew the electric field. Well, the Q depended upon how many extra electrons there were on the oil drop. And not every oil drop was the same size. Some were larger than others, some were smaller than others. Some had more electrons, some had less electrons. So what he had to do was painstakingly analyze all of the droplets that fell. And although he had a lot of data, he found that the value, the base value, they were all multiples of that 1.6 times 10 to the negative 19 coulombs. Now, of course, I'm simplifying his experiment for an introductory physics course. There's a lot more to it. And if you're interested in the Milikan oil drop experiment, you should look up more information in your textbook or online. But typically, he used the E equals F over Q and the V equals ED equations to find Q. And he found that every oil drop all had a multiple of that 1.6 times 10 to the negative 19 coulombs of charge. And he was able to work backwards and find that that was the smallest charge possible, and he found that that was the charge on the electron. Thank you. All right, now Robert Milikan was able to determine the charge in an electron. And basically what he did is he took oil droplets and shot them into an electric field. So when the oil droplets entered the field through this little hole here, they would fall. And what he found is that there was a charge on those particles, so he could adjust the voltage. He had this set up to a power supply, and he was able to change the voltage. So he had a variable power supply, which once again we'll discuss more in the current electricity section. Well, by changing the power supply, instead of falling at 9.8 meters per second squared, he was able to get them to fall at a constant velocity. Now, what that means is that they would fall at a constant velocity, gravity would act downward, and the electrostatic force would act up. So if this was the oil drop, I'll just make it oil, Fe was up and Fg was down. Well, he was able to determine that since these were equal, and we know that E equals F over Q, well, the E he set because he was able to change this. He knew the size, the distance between them. So using the VED equation, he was able to figure out, he set these two variables, new E. So now this is a known. he was able to tell that, well, if they're the same, then Fe is the same as force of gravity, so it's mg over q. He knew g. He found that the mass and the charge changed because he couldn't get every oil droplet to be the same. But he always found that it was a multiple, depending upon how big and how many extra electrons or protons there were on it, that it ended up being a multiple of 1.6 times 10 to the negative 19 coulombs. Now, of course, I'm oversimplifying this very complex situation, but effectively, because the oil droplet fell at a constant rate, he knew that it was in equilibrium. And because it was in equilibrium, gravity was equal to the electrostatic force, so he was able to use VED equals F over Q and F equals mg in order to figure out the charge of 1. And if you want to learn more about the Milikan oil drop experiment, I would suggest you look in your textbook or look for some more articles about Milikan.